All right, today I'm going to be walking through what I have been putting some hours into to get a proof of concept going with regards to a Microsoft Azure Cosmos DB, creating a function that then ultimately leads into our Power BI reports. And so initially what I did is I created a Cosmos DB account, and you'll see here that I have my Cosmos DB with our URI here. And then ultimately what we did is within the Data Explorer, we created a container. So this container is labeled Procore. I'm loading in the RFIs here. So I do this by creating a function. So I went through and created a function app. Within this function app, I created a JT Megan function, which then ultimately has the various types of resources that will go through and map it out. Through creating this function app, essentially what I did is I created the function app here, and what it will do is I created a few actual functions within this function app. The first one, sync RFIs to Cosmos. So what this will do is this will then go through and run the authentication for our Procore instance to go through and ultimately get the access token, be able to authenticate it against Procore, and then it will run all of that. And then once it's authenticated, essentially then it will connect to our Cosmos database, make sure that we're receiving all of the data that's currently there. And once it receives all of that data, essentially then it's going to fetch all of the RFIs for that project or for that Procore project. And then what it will do is it will then identify if there are any that are currently there already. If one was deleted, it will remove that from Cosmos. And if there's any updates or any new ones, it will add those into our Cosmos database. And so this will go through and insert all of that into our Cosmos database, and then it will run a bunch of code. This is all the logic that will go through and basically extract all of the RFIs. This is where it deletes an RFI if it's no longer existing. And then it will basically confirm that all of those were written to or wrote to the container within Cosmos. Once that runs, I do have a sync RFIs. So the other one was initially just to, it was initially to initialize the Procore authentication, and then it will get all of that to the container. I created a sync RFI, so this actually will then run and it will sync any new or updates to the RFIs to ensure that all of that's functioning. And then I created a timer essentially. So because there are webhooks, and I can actually pull this up here in our Procore instance. And within Procore, there are webhooks. So webhooks essentially will allow for us to go through and do like an automated check to see if there are any updates, and it'll automatically send that response to a post request endpoint. When I went through and looked at what available webhooks there are for Procore, it did not have any of the key ones that we're needing for. So we will need to do some form of polling request. But essentially, I went through, created a webhook here, and here are the resources that are available. There's 66 events, things like change orders, change events within construction financials, commitments, and then there's the core modules, which is mainly like projects and companies, and then the associated portfolios, that'd be like the projects that are updated or created. And then within project management, this is typically where we would see like the RFI, submittals, everything like that. There aren't those capabilities in there. So ultimately, this then requires us to go through and do a polling GET request to receive all of the RFIs, submittals, and various other things. So the idea here is that the webhooks can be used. They're a bit limited in this use case, given the data that we're looking to receive. So I created a trigger that will essentially go through and trigger the sync RFIs endpoint or function within the function app. And then we ultimately have a get RFI. So that would be like if I wanted to view all the RFIs. It's not necessary in this use case, but I added it just to like in the browser be able to visually see that the RFIs are there. And we can actually validate that the RFIs are there by going into our data and the data explorer within our Cosmos DB. And we'll see here our container that we created, and then here are all the RFIs that are then created. So these will load and consistently update based upon the trigger that is set within this instance. I did have it flatten some of the RFIs. It's not being ran right now. The reason for it flattening was my thought process is that loading the conditional objects and the arrays for the subdirectories, so like assignees or locations, may not be loaded within Power BI, which is not the case. And so this is actually omitted. And then ultimately we can fetch all the RFIs through, and that would be using the trigger to gather all the ones that are currently available in the Cosmos database. What I did then is I essentially went into my Power BI desktop, and you will see here that we have all of the data that is associated with it. So I created an RFIs object. How I did that was I did a get data. Well, I can click this button here, and this allows me to inject data. And so I did Cosmos, and within Cosmos I selected Cosmos Database version 2. I connected to it, and then this is where I would submit the Cosmos database endpoint, which essentially this is equal to this endpoint right here. So this URI for the Cosmos database. Once I submit that, and I guess I can submit it here just to show, this will then require an access key. So the access key is then found within the instance of our Cosmos database. It didn't require it this time because I already provisioned it, but in a sense this would then provide any type of data that is associated with it. So as you see here, the RFIs, assignees, ball and courts, and questions, those are all the sub-arrays for the RFIs. Essentially then we can load in all of this data depending on what we're looking to load in. And so when we go through and load all the questions, we have all of the responses here that are associated with the questions. We can load that in as a specific. I already did all this, so we should be good from there. So that essentially then brings in the RFIs, assignees, ball and courts, and questions, which then this data can then be referenced and leveraged within this display table or this workbook that we created. What I also did is I learned a little bit on how we can get the p6.xer file into Power BI. This is a bit different because it's a delineated file, meaning that there's specific data that's associated with it. So when we get the data here, we load this data, and we have to load it by a text CSV file. When we connect, we then reference the data that's associated with it. I have to choose all files here, and essentially this would leverage the P6 schedule. Once that's loaded, I ran some queries against that, and this basically then will partition the data, format it correctly. And so if we go into here, this would be the project, or I guess I'll do the task one here. I did a query. A Power Query essentially takes that 2D that 2D flat file, and then it delineates it further based upon the transformations that we schedule it for. So this is the initial source file that it loads in, and so as you know, this is not really usable. So I had to run some logic, and so I essentially went through and put together a transformation, and I believe it would be Advanced Editor here. And what I did is I did a task that then will run through all of this code to essentially partition the data and make it visible and usable. So what it does is it runs each of these, so it converts it to a table, and then it adds tags to it, so it takes out all the tags that are associated with it. It adds the values and delineates the tags versus the values, creates the table name. We then fill the table name. We filter based upon tasks, and so you'll see here that we have our tasks that are associated with it. We provision the headers for it. once we have the headers, we count how many headers there are and how many rows. We then format the rows, and then we split the rows within the data. So then what this does is we can normalize it to make sure that it runs well, and then we put them into a column. And then this basically makes it into a readable format that is then usable, that we can and then input into Power BI. So once this data is in Power BI, essentially then what we can do is run that query. That query then gives us all of the associated headers that we formatted from it, which then ultimately I load it into here. So you'll see here, this is the RFIs. So I created a graph that shows the schedule impact based on status, and then we can load in all of the RFIs that are associated with that. And so I did that by selecting these specific fields for it, and then I did the same thing for the schedule here. So within the schedule, I had the scheduled tasks, and then we are specifically pulling key attributes here, and then I created a Gantt chart visualization, so then this can be viewable and seen, referenced. What I did then is, this is on Power BI desktop, and so I then essentially went through and pressed file and then published this and published to Power BI. It's already published, and so I can show you essentially what it looks like. One thing I did forget to mention is, once this function app is created, I then had to go through and actually publish this and deploy it to Azure. So once this is published to Azure, it will then load all of these functions that we created and then provision those, so then they are ran. And then it's automatically running this trigger, so it'll automatically trigger the sync RFIs endpoint. Once it syncs all the RFIs, that will then update all of the data that's in our Cosmos database here. And so when we go through in the Data Explorer, it'll automatically update this based upon it gathering all of that data for the RFIs, which then leads into updating our data source. So then what we do is, once this is provisioned, this Power BI report is provisioned, it's synced with that Cosmos database, it'll always update on that periodic cadence. Specifically though, once we push this into Power BI, I have a workspace that's created. Within this workspace, essentially this is pulling in all of that data, and it's linked to the specific resources. So what I had to do is, I had to go through in the settings section here, I managed the connections and gateways. So I created gateways that are associated with the schedule. So here's the schedule here that is then pulling my schedule from the on-prem version, which actually is this one. It's not the personal one. And so I provisioned a file, which this file then is then being referenced to that specific file location where that's at. And then I provisioned the Cosmos database, and so then I plugged in the credentials for the Cosmos database and the key associated with it, similar to what we did before. So then essentially what this will go through and do is, it creates the workspace. Within this workspace, it then pulls in the Power BI dashboard project that we created, which then has all of the data associated with it. So this pulls in all of the data, which is then interactable. You can reference all of the data. We can create any charts. We can filter all the data to make sure that it is visible to what your needs are. And then ultimately, from there, it should be good to go and running. What I did do is, I went through and within the data sets, we can then set a scheduled refresh. So what the scheduled refresh will do is, this actually will then run and essentially then provision and gather the new data that is pulled from the Data Explorer Cosmos DB, as well as then any file. So it'll still reference that main file. So if we have it given a specific name for that file, like maybe current schedule, and it's in the same location, anytime that current schedule, then it will always be refreshed based upon the scheduled refresh that we provision it here. And so this is ultimately then the dashboard that is created for a sample, pulling in all of the RFIs. Of course, we can pull in any data set from Procore. All we'd have to do is create a new app function and have it run. And then it will go through and also pull in all of the P6 schedule, and that's based upon a file that's on a server that we can then reference a specific name for. Anyways, I hope that helps explain everything that's been done to this point, gives a great overview in detail into what's capable and what's possible. Of course, this is just the tip of the iceberg, but eager for your feedback, and I appreciate the time and opportunity.